All right. Equation solving in trig. We introed this idea yesterday off worksheet 23, maybe. Remember on the back it said something like, where's the sine equal to 1/2? And we talked about finding that spot on the unit circle and saying it could go repeat every 2 pi. All right, and then there was another place where that was true, and it would repeat every 2 pi. That's exactly what we're doing today, but they're gonna be more complicated than just saying sine x equals 1/2. All right, so does everybody have out a unit circle? If you're not looking at your unit circle and finding these values and understanding where I get them, this is just gonna seem like Hofbauer magic, okay? And Hofbauer magic isn't gonna help you on your homework or your test or quiz. You gotta know where this is coming from, so if you don't get it, please ask. All right, so we did this kind of question yesterday. Where's the cosine 1/2? We looked at our unit circle. Cosine is x. It happened at pi over 3. And it also happened on the unit circle that the x value was 1/2 over at 5 pi over 3. Okay? Then because it says all solutions, okay, just says x here, it doesn't say arc cosine or inverse cosine, which would only have one solution. It's an equation, so x can repeat. So then we put on this plus or minus 2 pi thing, okay? Let's talk about all right. So at the top of your notes, it does suggest that you may need to isolate a trig function. You may need to take the square root of each side. And when you do that, remember your plus or minus. You may need to factor, you can do a lot of that, and apply the zero product property. That just means when you factor and two things multiply to make 0, you set each one equal to 0, that whole thing, okay? It says apply the quadratic formula. Yeah, I didn't assign anywhere you had to use quadratic formula. Rewrite into a single trig function, okay? And that we're going to do more tomorrow, where it's going to give you things like secant times tangent equals, and you have to do some trading before you can even solve. Today there's a couple where we have to do a trade. I won't say there aren't any, but mostly we're just solving. All right. Moving to this slide, this is an example, and I'm just going to pretend that it's not worked out, but you don't need to write it down that way, okay? When I see this, I think, well, there's a cosine here and a cosine here, so I'm going to factor that out. Then it would say tangent of x, if I took the cosine out, minus 1. Everybody okay? Then I play the take your turn being equal to 0 game. This could equal 0, or this could equal 0. The cosine is 0. Can you look at your unit circle and tell me where that's true? Where's the cosine 0? Pi over 2 and 3 pi over 2. Okay? And then if we set this one equal, we'd get the tangent is equal to 1. Where is the tangent equal to 1? Now remember, tangent's not on there. Tangent is hard. You have to think. But where the sine and cosine are the same, when you put one over the other, the tangent would be 1. So it's at pi over 4 and... Okay. Now this particular question says we only need to answer on the unit circle. We don't have to put any plus or minus 2 pi n's because it says only between 0 and 2 pi. So we came up with 4 solutions. This is a very tricky question because at this spot here, when we said the cosine was 0, look at that spot at 3 pi over 2. Can I put a tangent value in at 3 pi over 2? Tangent would be 1 over 0, would be undefined. So, well, when we plugged 3 pi over 2 in, we'd get undefined times 0 minus 0 equals 0. You and I would kind of go, yeah, that's probably okay. But whenever there's an undefined, it's just undefined. You can't do it. So we have to throw these two out. I'm going to talk later on today about graphing this. This would have been a perfect question to graph tangent times cosine minus cosine, all in y1, and plug this interval into your window, 0 to 2 pi, and you would see that there's only 2 spots where it crosses 0, so you would know right away, even though I got 4 solutions, there must be a problem, okay? I'm going to talk about that more later today, but this was definitely a tricky one because we had to throw out these 2 solutions because they make tangent undefined. All right, moving on. Here's an example. You guys don't have this one, but you would subtract 1 and get 3. You would divide by 4. And then to get the sign by itself, you would square root, remembering plus or minus. Square root of 3 is just square root of 3. Square root of 4 is 2. And then because it says plus or minus, there would actually be 4 places where the sign is square root of 3 over 2. Here, positive, and down here, negative. So you'd have 4 solutions. Everybody okay? When it says you have to find all solutions with no interval, like 0 to 2 pi given, the solution will be represented with whatever you find for your answer. I'm sorry, guys. Plus or minus 2 pi. N is the way I usually write it. They write 2n pi. If it's a sine or cosine graph, and if it's a tangent graph, that actually repeats every pi. So you would say, I found an answer plus pi n, plus or minus. So here's a problem that looks kind of funky. What you would do is add sine x over to the other side so that you had a 0. Now what's sine x plus sine x, guys? 2 sine x, okay? Plus square root of 3 equals 0. Then you would solve to get the sine x by itself. So you would subtract square root of 3 and divide by 2, and you'd get here. Look at your unit circle. Where does that happen? The y value is negative square root of 3 over 2. It's going to be down in the bottom half of your unit circle where y is negative. You get these 2 answers, right? And then because it says all solutions, not just the ones between 0 and 2 pi, you have to throw this on the back. Everybody okay? Let's try one. This one's pretty basic. It says all solutions though, okay? Where's the cosine negative 1? Look at your unit circle, tell me where the x value for cosine is negative 1. It only happens at pi, right? But if I want all solutions, how often would that repeat? Because it's a cosine, the period is 2 pi. So your book would write just pi plus 2n pi? Is that where they put it? Or n 2 pi? I don't remember. 2n pi. That just seems very odd to me. Because pi is a number, right? Anyway, I always write 2 pi n. Because 2 and pi are numbers and n is a variable. But okay. I just realized that was strange. Sorry. I've only been teaching this lesson twice. But all right. When trig functions cannot be combined on one side, try factoring. Okay, that's what we just did. I don't know why this slide is here. We're going to talk about this in a second, but when you see this, actually, if you saw that, some of you would be tempted to divide both sides by cosine. Okay? You can't do that because you will lose one of the possible solutions. You have to move it over to the other side and factor the cosine out. All right? We'll talk more about that as we go. All right, this first one looks kind of miserable. Anybody have a suggestion? Factor out a sign, and then what happens? Because this term and this term, separated by a subtraction, both have a sign. We get what? sine squared minus 4. Good job, equals 0. When you get confused about the factoring, just think of it like u cubed minus 4u. Well, if I saw that, I'd take out a u, and then I'd have u squared minus 4, and how would I factor that? U minus 2u plus 2. We're going to do the same thing, okay? This is going to be sine x minus 2 and sine x plus 2, if I can write. Okay? Now what? We are using our zero product property. Did you know that? We're going to set each one equal to 0. So the sine x equals 0, or sine x minus 2 equals 0, which would make the sine 2, or the sine x plus 2 equals 0, which would make it negative 2. Anybody have little alarm bells going off in their head yet? Can sine ever be 2 or negative 2? Picture the graph. Only goes up to 1 or negative 1, right? We get to throw all these away. The only way that this is true, that the sine cubed minus 4 sine x is 0, is where the sine is actually 0, which occurs at, okay, pi and 2 pi. Normally we call 2 pi 0 to start, because you say the first, if you pictured the graph, and I asked you where the sine was 0, you would say 0, pi, 2 pi, right? So we're going to say at 0 and at pi, and then it repeats every how often? Okay, that's what your book answers, which is kind of interesting to me, because your book just goes with find it on the unit circle and then add 2 pi. This is one that a lot of books and a lot of calculus teachers someday would talk about a shorter way to write that. If you start at 0, how often do you actually hit 0 again on the sine graph? Every pi, right? So you could write just 0 plus pi n, or just write pi n. This is a shorter way to write it. I don't care what you do, okay? Which makes grading these on a test or quiz really fun, because there's lots of ways you can write them. But I don't care. The longer way is fine. The shorter way is also fine. Now that's not a shortcut you can use for everything. It just so happens that this one shows up every pi, right? The answer. We'll keep talking about this as we go. Now what? Factor out cosine. Good job. What will we have left? Okay. Cosine equals 0. Sine equals 3. Nice. Sine's not possible. Excellent. You guys are on the ball here. Cosine is 0. Now, again, that repeats every 2 pi because it's a cosine graph. So this is a perfectly good solution. Anybody think they can shorten that up? Look where they are on the unit circle. Those two, are they straight across from each other? So it's actually every pi. So you could say this. Okay. You could say it starts at pi over 2 and then it goes straight across to the next answer. You could actually say this. Says you could go up to pi over 2 or down to negative pi over 2 and then continue around multiples. You could even change that to a 1 pi n because they're straight across from each other. It's fine to just stick with this though. These are the two places on the unit circle and the cosine repeats every 2 pi. Don't feel like you have to get fancy and get something wrong. Okay, this is one where somebody's going to be tempted to divide both sides by sine. Instead, we need to subtract it over. Then what? Factor out a sine. Now this one we're not going to get to throw away a bunch of stuff. 2 sine squared minus 1 doesn't really factor, right? Further. So we have the sine is equal to 0, or 2 sine squared minus 1 equals 0. What can we do with this one on the right? Add the 1, divide by 2, and we get sine squared as a half. But I don't have a sine squared on my unit circle. I only have a sine. If I square root 1/2, first of all, because I square rooted something with an x, I need to remember it could be positive or negative, right? Square root of 1 is 1. Square root of 2 in the denominator looks like this, but how is that written on my unit circle? Okay, and it's plus or minus, so there's a whole bunch of those on my unit circle, right? This is a weird one because you could write this one a bunch of different ways as well. Let's start with this guy before we forget. Where is the sine 0?
0.
Okay, 0 and pi, and because it's sine, it repeats every 2 pi. Definitely shorter way to write that, but that would work. Where is the sine? Let's start with positive, square root of 2 over 2. Where else is the sine positive, square root of 2 over 2? All right, where is it negative, square root of 2 over 2? Okay, so it would be fine with me if you left all of those answers. Who thinks they could shorten that up? What do you think, guys? Does that cover all of them?
Yeah. Because they're all pi away from each other.
If you look at your unit circle, if you start at pi over 4 and go straight across, you've covered 5 pi over 4. But have you covered the 3 and 7? If you wanted to write this really short, you could do this. Why does that cover 3 and 7? Because you could go up 90 and straight across, or up 45 and straight across, or down 45 and straight across, and now you've covered all of them. Anybody have a better one or another one? This one as well, you could have just said 0 plus or minus pi n. Okay, so that's a shortened way. Actually, if you start at 45, doesn't it add 90 every time? So somebody suggested we could write pi over 4 plus or minus pi over 2n for this one. That would also work. Okay. I'm just going to confuse some of you, so let's just keep going. That only works for the pi over 4s, by the way. If you're at 30 degrees, you have to go further, right, to get to the next reference angle of 30, so it doesn't work. Okay. Try 5 on your own. Oh, maybe not.
No, it's
new directions. Yes?
Yeah.
Easier directions. You're going to like these directions. It says 0 to 2 pi. No plus or minus anything. When you see this, it means you're not going to add plus or minus 2 pi n or 1 pi n or pi over 2n. Okay? It just wants the answers on the unit circle. All right. Be careful. It includes 0 but not 2 pi. So for example, if it asked where the cosine is 1, look at your unit circle. Cosine is 1. You would say 0 but not 2 pi because of the soft bracket, okay? All right, answer this question. On the unit circle, where is 2 times the cosine equal to 1? Pi over 3 and? Does everybody see that that's the 2 places where the x value is positive 1/2. That's it. We're done. If it had said all solutions, we'd throw a plus or minus 2 pi n on the back and be done. All right, number 6, what do you think? This is written kind of weird, but 5 minus 7 is 2, right? Or we could move all that over to the other side like we're going to anyway. 2 sine x equals negative 2. Be careful. I got negative 1. Did anybody else do it? If you add 7 and subtract 5, you get 2. Wow, what'd I do? This is a negative. Is it positive 1, guys? Okay, thanks. Yep. Yep. I did it wrong. First to admit. All right, so where is the sign 1 on the unit circle? Sign is the y coordinate. It is at pi over 2. Is it anywhere else? Nope, the only place the sign, think about the sign graph, the only place it hits 1 is right here at pi over 2, okay? All right. Now what? Yes, nicely done. We have to move the tangent to the other side. We can't divide it out. Factor out a tangent. We have where's the tangent equal to 0, and what does this become? What? If the 4 wasn't there, yes. If the 4 wasn't there, yes. But no. We have the sine squared is 1/4. What do we need to do? Square root, and remember your plus or minus. Oh, I lost my x. So I have the sine of x equals plus or minus the square root of 1 is 1, the square root of 4 is 2, square root of 4 is just 2. Thank you, Hoffbauer. What's you writing there? Okay, that's it, right? Okay, so the tangent is 0, occurs at y over x. 0 and pi. And remember, we don't have to add a plus or minus because it still says on the interval 0 to 2 pi. Yeah, I was getting ready to put some on too. Where's the sign positive 1/2? Okay. And one more spot where it's positive. 5, 6. And where's the sign negative 1/2? And okay, so we're thinking we have this many solutions. Back to the original question, we just need to make sure that those are defined at all places, nothing's undefined. But the tangent is defined at 0 and pi, right? If you look at your unit circle, or if you think about the tangent, it's 0 at both those places, so we're good. That's the worst graph ever. Okay. Can you guys try this one? Everybody okay?
Yeah.
That's it, because it said between 0 and 2 pi, right? Mm-hmm. All right. You will also have to do a few problems, eventually more than a few, where you will have to do some trig identity trades. Okay? when you do the trading, be careful to check all the solutions to make sure that they are valid. Now, the easiest way to check is honestly to graph, but this particular problem would kind of be a nightmare to graph because, well, 2 tangent squared minus, and then this would have to be 1 over cosine squared in your calculator, plus 3. When you graph, and we'll do these in a minute, you would graph like this in y1 and this in y2 and see how many times it intersected in this interval so that you knew how many solutions you were looking for. That way you would know, I got 4 solutions, but when I look at the graph it only has 2, so I need to figure out which 2 don't work. All right, this particular one is kind of painful. I'm going to write it down as though, here, let me do this. The only chance you really have of understanding is if we go through it. If you just try to follow their work, it's kind of tricky. Okay, that didn't work so well. Where's my little thing? Okay, there it worked. I don't know what happened. All right, we're going to replace this because everywhere else in the problem is a tangent. What can I replace secant squared with? Secant squared, according to the little chart on the top of my unit circle sheet, is tangent squared plus 1. Everybody all right? Okay. So I have 2 tangent squared minus, I distribute that negative, and I get minus a tangent squared minus 1 plus 3 equals 1 minus 2 tangent of x. Okay. The negative 1 plus 3 is 2. If I subtract this 1, combine those and I get what? 2 tangent squared minus 1 tangent squared is tangent squared. This all became a minus 1. What else? We're going to have to factor. We're going to have to add this over here and make it 0. No, we can't take out a tangent. But it's like it says u squared plus 2u minus 1. What did I do wrong, Josh? Right here. Yes, I think I copied this. Did I copy? Yes. It was this 2 minus 1. This should be a plus 1. Thank you. Yep, you're right. All right. This is like I have a u squared plus 2u plus 1. Does that factor, guys? U plus 1 times u plus 1, right? So this is going to factor tangent of x plus 1 times tangent of x plus 1. So the only place I have a solution is where the tangent of x equals what? Negative 1. Now remember, tangent's not on your unit circle. You have to think carefully. 7 pi over 4 I heard. Is that true? Okay, where else? Guys, put your phones away, please. I have 3 pi over 4 and 7 pi over 4. What do you notice about those, though, when you look at the unit circle? They're right across from each other. And honestly, what is tangents period anyway? Pi. So if you find one of them and say they repeat every pi, you're good to go. It doesn't matter which one, or even if you wrote both. Okay. I wouldn't count wrong if you wrote both. All right, and that's what they had for a solution, right? Oh, he didn't tell me it had an interval 0 to 2 pi. Thank you. So should I have put this plus or minus on the end?
No.
I should have just left it these two. because I didn't read directions. I didn't have directions on my page. Okay. Once again, this is a weird example where you have to square both sides. I don't think there's one on tonight's homework, but we're only looking in this interval. There is not a trade for 1 plus plain old cosine. Does everybody understand that? If it had a cosine squared, we could figure something out, but it doesn't. So what they do is they square both sides, which gives them 1 plus 2 cosine plus cosine squared all equals sine squared. Then they get rid of sine squared in terms of cosine squared, because now that everything is in terms of cosine, they can do some adding and subtracting and messing around, and then it factors something out and blah, blah, blah. And they get the solution where the cosine is 0 is at pi over 2 and 3 pi over 2, and cosine is negative 1 at pi, so they add 3 solutions. Like I said, I don't think there's one like that on today's, so let's get started. Number 9. What are we going to do here? Square root, and the square root of 1 is just 1. But what is the square root of tangent squared? Except you got to remember, when you square root anything with an x, you need plus or minus. Okay. Tangent's not really on the unit circle. You have to think a little bit. I need this x coordinate and the y coordinate to be the same. Okay, so I'm looking at this spot. And a plus or minus, right? Because no matter what, any of those are plus or minus. So I'd have pi over 4, 3 pi over 4, it's negative, 5 pi over 4, 7 pi over 4. Do you really need all those? Because tangent has a period of what? Pi, so they're straight across from each other. So if you give me 2 of them and tell me plus pi would be good. That's one again where you could tell me actually if I keep adding pi over 2 I'd get to the next one. So the shortest way to write that. But I'm not going to, most of you wouldn't get that. You got a question?
No.
Okay. Can I factor something out? I can add 1 over, but I'm still at a stuck spot. Any ideas? Divide by 2 isn't going to help because then we have cosine over 2.
Add that cosine over and then square it. No.
We could add the cosine over the other side and square both sides. I would do a substitution from the beginning so that I didn't have to square both sides. I can't get rid of cosine, but what can I trade the sine squared for? So that I only have cosines. If I trade sine squared for 1 minus cosine squared, now maybe I can factor because I'm down to only cosines, right? Let's see what happens. I move the 1 over. If I multiply the 2 through here, if I combine these guys, now you can factor it like that. I get it wrong every time. I don't like a negative out here. So yeah, I can move everything to the other side, or I could multiply through by a negative 1. It doesn't matter. It's the same thing. So if I move it all, I would have 2 cosine squared plus cosine of x minus 1. I just don't like dealing with a negative a coefficient when I go to factor. All right, so what will multiply to make 2 cosine squared? 2 cosine times a cosine. I need a plus 1 and a minus 1. Be careful. I need a plus 1 in here, so I need that one to be plus and this one to be minus. Everybody okay? All right, so what values of cosine am I actually looking for?
Or -1 and 1/2.
2 cosine of x minus 1 equals 0 would be positive 1/2, right? I thought I heard a negative. We okay? And the cosine of x from this one would be -1. All right, I've forgotten the directions. Do we want all or just on an interval? All? Okay. Where is the cosine 1/2? Pi over 3 and 5 pi over 3? Anybody know a shorter way to write that? Nobody? If you picture the cosine graph, what kind of a function is it? So the solution is pi over 3 to the left or pi over 3 to the right. So the shorter way would be to say plus or minus pi over 3 plus or minus 2 pi n. That would cover both. But I'm fine. Just leave it like this. The book even leaves it like this, I think. Where's the cosine -1? At pi, and that's it, right? So we'd have to add 2 pi n to that. Everybody okay?
Yeah.
All right, this one suggests we graph to find all solutions to make sure we've found all our solutions, but this is a really weird question. If you try to overthink this one, you could make it a big disaster, okay? You could square some things and then trade out a cosine squared for a sine squared -1 and do a whole bunch of junk. But think about the unit circle. Where are the cosine and the sine or the x and the y value exactly the same?
5/4.
Is that it?
Bam. Yeah.
They're either both positive square root of 2 over 2 or both negative square root of 2 over 2, and that's it, right?
Yeah.
Okay. Because it does say we only want the answers between 0 and 2 pi, that means we need no plus or minus garbage. I'm going to do this super fast, except you know how not super fast I type here. The original equation said sine of x is equal to cosine of x. And it said between 0 and 2 pi. So if I set my window, I'm going to do a zoom trig first. Zoom trig, but then I'm going to go and change my window to 0 to 2 pi. Everybody got their calculator out? Second, so we can do some of these? Okay, here's in the window 0 to 2 pi, here's the cosine and the sine graph. How many times do they cross? Twice. Did I find 2 solutions? Okay. If I wanted to go even further and check, I could go trace and type pi over 4. If I could type. And it would jump to one of the solutions, okay? One of the solutions is right here at pi over 4. And the other one would be at 5 pi over 4, okay? So you could check your answers. But most importantly, you can check that there should only be 2. And not 1 or 0. Okay, number 14. What do you want to start here? Factor out a cosine, and it will say square root of 3 tangent of x minus 1. So the cosine of x equals 0. Or square root of 3 tangent of x minus 1 equals 0, which would make the tangent of x equal to 1 over square root of 3. Can I leave it like that? Is that actually easy? I'm looking for where that happens, right? I don't really want the value. So I'm going to leave it like that because it's easier to look for where the y has a 1 and the x has a square root of 3. It doesn't matter. It's just hard to find the tangent on my unit circle, and this is actually easier to look for. I need a 1 back here in my parenthesis and a square root of 3 here. Remember, the denominators look like this, but they cancel out when we divide them out to make tangent. Okay? Also, where they're both negative would make a positive, right? Okay. It says only on the interval 0 to 2 pi. Don't need any plus or minuses. All right, where's the cosine 0, first of all? Is that the only spot? 3 pi over 2. Okay. What about where's the tangent have, or where does there a point that looks like this? Pi over 6 and 7 pi over 6, which is straight across, right? Because tangent repeats every pi. All right, let's type it in and see if we actually get 4 solutions. This one says equals 0, so that's the way I'm going to type it. I'm going to put it all in y1. I'm going to type square root of 3. If you have an older calculator, you want to close the parenthesis. Otherwise, you want to arrow to the right. So it's just the square root of 3. Nothing else is under the square root. Then times cosine x, tan x, close all your little parentheses, minus cosine x. If you haven't already done so, make sure you make your window 0 to 2 pi and like negative 4 to 4. Okay, this is what I get. What am I looking for? Where it crosses the x-axis. How many times did it cross the x-axis? 2. So I have a problem. I wrote down 4 solutions. The problem is always with the ones that have asymptotes, guys. What has an asymptote? Cosine or tangent? Tangent. Do you know where the tangent has asymptotes at? Pi over 2. This is not a solution, and this is not a solution because the tangent is undefined there. All right, so the only 2 solutions are pi over 6, 7 pi over 6. Can I check that? Pi divided, well, trace first. Pi divided by 6, it jumps to a 0. Okay? All right, we will practice some more of these tomorrow. Even if you're not done with all the proof stuff tonight, try 3 or 4 of these, or try like 2 that are all solutions and 2 that have an interval solution. Just because tomorrow we're going to get to the trickier ones. I'd like you to practice a couple easy ones tonight, okay? Day 2 on this stuff tomorrow, and the homework check is due.